Structured programming is a fundamental approach to coding that enhances clarity, efficiency, and maintainability. It is based on the principle that a program should be broken down into smaller, manageable sections, using clear and logical control structures, such as sequence, selection, and iteration. This method ensures that the flow of execution is predictable, making it easier to design, test, and modify programs as needed. One of the core advantages of structured programming is that it simplifies the coding process by enforcing a logical structure. When a program is written in a structured way, each section performs a distinct function, which makes it easier to read and understand. The use of functions, procedures, or subroutines means that a programmer can focus on individual components rather than trying to grasp the entire code base at once. This modular approach is particularly beneficial for larger programs, where maintaining organization and clarity is crucial. Another significant advantage is that structured programming promotes reusability. By breaking a program into smaller sections, common tasks can be written once and reused multiple times throughout the program. This reduces redundancy and minimizes the risk of errors, as changes to a specific function will automatically reflect wherever that function is used. The use of clearly defined blocks also improves collaboration among developers, as different team members can work on separate modules without interfering with each other's code. Testing and debugging are made significantly easier when structured programming is applied. Since each section of the program is independent and self-contained, errors can be identified and resolved in isolation without affecting the rest of the code. Structured programming encourages the use of meaningful variable names, consistent indentation, and clear comments, all of which contribute to easier debugging and troubleshooting. When an error does occur, it is much simpler to pinpoint the exact location of the problem rather than having to sift through a tangled mass of unstructured code. A key consideration in programming is maintainability, which refers to how easily a program can be modified or expanded. A well-structured program ensures that future changes, whether they involve adding new features, fixing bugs, or optimizing performance, can be carried out with minimal disruption. If a program is written without structure, making modifications can become a daunting task, often requiring a complete rewrite of significant portions of code. Structured programming eliminates this issue by allowing modifications to be made in specific sections without altering the overall functionality of the program. Good software design also accounts for scalability, ensuring that as new requirements arise, the program can be expanded efficiently. A structured program makes it easier to integrate additional features without compromising the stability of existing code. Since different modules handle distinct tasks, new functions can be added without interfering with the main program logic. This is particularly useful in modern software development, where applications frequently evolve to meet changing user needs. Structured programming also reduces the likelihood of logical errors by enforcing a disciplined approach to coding. The use of control structures such as loops and conditional statements ensures that the program follows a predictable flow. This predictability makes it easier to trace the execution of the program and verify that it produces the expected results. Unstructured code, on the other hand, often leads to spaghetti code, where logic is scattered across the program with little regard for readability or organization. Spaghetti code is notoriously difficult to debug and maintain, leading to inefficiencies in both development and long-term upkeep. Another benefit of structured programming is that it aligns well with modern programming languages and paradigms. Many high-level programming languages, such as Python, Java, and C++, encourage structured programming principles by supporting functions, loops, and conditional statements. Adopting structured programming techniques ensures that a program remains compatible with industry standards and best practices, making it easier to work with third-party libraries, frameworks, and APIs. By following structured programming principles, developers can ensure that their programs are not only functional, but also well-organized, efficient, and easy to maintain. Whether working on a small script or a complex application, structuring code logically improves readability, enhances collaboration, simplifies debugging, and future-proofs the software against potential changes. Investing in structured programming techniques ultimately results in better software development practices, leading to higher quality programs that are reliable, scalable, and adaptable to evolving requirements.